Hello everyone, myself Nishitha, Assistant Professor, Department of CSIT, working at MLR Institute of Technology. In previous sessions, we have discussed about mass storage structure. In this mass storage structure, we have discussed about disk attachments, disk scheduling algorithms. In that disk scheduling algorithms, we already discussed about FCFS, scan, C-scan, look and C-look. So that are the different types of disk scheduling algorithms. So in this session, we are going to see about input-output hardware in operating system. So let us see the overview of this presentation. So in this overview of this presentation, we are going to discuss about input-output hardware in operating system. How this input-output hardware is working on the operating system. So in this input-output hardware system, it is a specialized hardware devices that help the operating system to access the disk drives, printers and other peripheral devices. So whatever you are accessing with the input operations, suppose input I am using some C language code to access some input code. So what I want to write the addition of two numbers. So I am doing the addition of two numbers. So for this I am giving 2 plus 3 and what is the output for this? 5. So how we are going to give the input, on what basis the output is performed. So based on the input you are giving to write the code in C language and you are performing some addition. So in that addition we are getting the output of two values. So that is how we are going to operate the input based operating system. And what is the out based operating system? How you are performing, on what basis the code is running. So giving the input as a C language code, performing addition of two numbers, and output you are getting the addition of the two numbers. So whatever you are performing, that is based on this input output hardware of the operating system. So these devices are located inside the motherboard and connected to the processor using a bus. So all these devices are connected inside the motherboard, either maybe disk drives or any peripheral devices or any other hard drives. So whatever these drives are presented, all are present in the inside of the motherboard and that are connected to the processor by using a connection called bus. So this connection to the all devices by using a bus. Bus is a connection where it can connect input output devices. The daisy chain, expansion bus, controller and host adapter are used to access the input output hardware. So in some cases the bus of these devices who all are controlling these adapters, maybe either it is a laptop adapter or any adapters that can host to access some input output hardwares based on this daisy chain. So whatever you are performing the operations, that can be helped with the use of accessing the input output hardware. The daisy chain is a method of connecting multiple input output devices. So this chain helps in the connection of multiple input output devices. So it can connect n number of inputs and output devices by using this daisy chain with each other through a single connection point. So whatever you are connecting, this all the connections are placed at a single point, that is what connecting point pin. So all these connections are connected to some pins, that one connection is connected as pin. Each device can be accessed by plugging into any of the pins which are connected to the connection point. All the plugging pins are connected to some sockets and that connections are connected to some connecting points. So that are the connections within the input and output hardwares. The expansion bus connects devices together. So the expansion bus can be connected together in parallel with each other, so that can be accessed simultaneously by using only one cable instead of several cables. So whatever the bus which is connected from one after the other, that are connected parallelly and they are accessed simultaneously instead of several cables. So after applying or connecting each and every cable to the system, so only one after the other can be connect or perform easily. Why? Because if there are several cables or several connections are performing at a time, that may be hacked or get some buffering. This design allows you to connect more than one peripheral device. So this design will be helping to connect one or more n number of peripheral devices at a time, while maintaining compatibility with older system that may not support additional peripherals. So when you are comparing with the older system to the newer system, which will be the higher accessible speed will be more. So comparing to old system, the new system will be accessed very frequently, and the supporting of the additional features of the peripheral devices also gets more active when compared to the old system. Why? Because when the old system performing the action is very slow, when we are comparing with the new system, the action is very high. So that is how they are going to perform or support the additional features of these peripheral devices. So that may be such as memory mapped input output. So the memory may be RAM or ROM that can be mapped with the input output hardware. So this can be accessed through memory mapped input output hardware in operating system. So let us see about polling. So polling is nothing but it is used to check the status of all the devices. So what are the working conditions and what are the device connections, what is the status of each device, that can be accessed or that can be checked through this polling. Polling is a software technique that uses a program to check the status of all the devices. So it is to check the status of each and every device in the system. This device can be a disk drive or any other peripheral device in the computer. So this disk either may be a peripheral device or any other disk drive in the computer system. The program polls the device for any information such as it is a data available or not. So when the data is available in the program polls, it says the information that the data is present, or if the information is present, it is say data is available. If the information is not present, it says data is not available. Polling is a slow way to get data from a device because it has to wait until another function occurs before being able to get the information about its state. So until and unless the device which is getting the data, so here the polling is a slow way. It is a slowly to check one device connection. So it is checking some device status and the data which is having in the function or not, it is available or not, and the function should next device or any other function should wait until and unless it gives the information of the present working device or any file folder. So if the device file folder found, then it takes the next file to check it is available or not. So that is giving the information or correct status of a present system. So information or giving the present status of the any device, that is polling. In some cases, polling may be desirable. So it may be desirable. For example, when there are several items being polled simultaneously, only one updates its state any time. So here the polling may be desirable. So it may sometimes it may be attached or detached. When there are several items being polled simultaneously, one after the other, they are going on checking the status. So one item updates its state at any time. So it may get the status of that device at any time. The rest continue wait until they receive an acknowledgement. So here if the status of the first device is completed and the next device is waiting to check its status. So until and unless we get the acknowledgement of the first device, then only it accepts the second device. Until and unless it completes its device status, then only it accepts the next device for its acknowledgement. From one item that it's not done updating their states. So one after the other, getting its states to be acknowledged from the receiver. Either it is currently working or it is not working, it will be given by the polling status information. Whereas if it is not received, we get an acknowledgement that there is no available of this device or any data is not available. So if it is not available, it takes another device and it starts checking the next device for the status. Polling can also be used to check if a device is online or not. So it also checks whether it is in online or not. If the device is offline, then this information can be take some appropriate action, can be pausing or suspending task. So when we are having internet through online, so we can check the device directly whether it is present or not. Why? Because we are having high internet speed, so that we can say the availability of these devices or not. If it is offline, the information can be used to take more appropriate action, such as pausing or suspending some tasks that depend on the device, stopping a backup in progress. So whatever you need the information of the device, it is present or not. When the online is present, we can say it is present or not. When it is offline, it takes more appropriate action by pausing or suspending its task depend on what you are choosing the device. So stopping a backup in the progress. So it stops some backup progress at the end, back end. So that is how the polling is done in the input output hardware. So first it checks the status of each and every device, whether it is present or not. If it is online, it goes speed. If it is offline, it takes some appropriate actions, whether to pause or suspend some task. So this is what polling in input output hardware operating system. So next is interrupts. So what do I mean by interrupts? Interrupts is nothing but an error. So when you are accessing or when you are sharing some information, if any buffering or any error occurs, what happens? So how the input output hardware takes the actions in the interrupts. So let us see with the interrupts. The CPU is interrupted by several different devices, such as input output hardware and peripheral devices. So it is interrupted with several different types of devices that are nothing but input output hardwares and any other peripheral devices. These interrupts are used by the input output devices to notify the CPU when it needs some attention. So whatever the input output device, it is notified to the CPU, it needs some action to perform whether the interrupt occurred or not. If an error occurred, then they perform some action to rectify that error. The CPU can be interrupted by several different devices at any given time. So the CPU may get any interrupts at any several different types of devices at any given time. But only one interrupt will be delivered to it any given time. So if there are n number of errors, so when you are accessing these errors, each and every error will be checked at a time? No. So one after the other. So that is what only one interrupt will be delivered at the given time. So one after the other, whatever the interrupts or any errors occurs, so it can be solved by one. That is what it can be solved only one at a given time. This can happen because of a hardware or software error occurring. So this is happening when it is by hardware or software by this input output bus. So these errors occur when it is an hardware or software. These errors will be occurring through an input output bus. For example, if a disk drive has failed, then all the other data transfers will pass until it's repaired. So whatever the data which you are sending, while sending you have some error, so the data is encrypted or decrypted. So the disk drive gets an error, that is you cannot pass the data. Why? Because an interrupts occur. So you fail to send the data or receive the data from client and server. So this is how the errors occur during hardware or software. Or perhaps another device wants to access memory or vice versa. So it may be take some other perhaps another devices that can access to the memory in vice versa. In other case, there won't be any way for your application program not be written specifically for this particular machine. So they cannot be written in specific manner to perform this particular action. Why? Because you are getting an error when the hardware and software have some input output buffering. So the application program which you are written specifically, that can be happen to that particular machine. So this errorings or this bufferings happens when you are passing some information to client and server or receiving the data from client and server. So these errors will be occurred frequently while using some data transferring. So this is how the interrupts occur in the input output hardware of the operating system. So let us see how this happens. CPU and input output controller. So device drivers initiates input output sending. So input output it is going to send. And next input output completes or error generates interrupt signal. So when you are passing some input output operation here, then if an error occurred or it raises some signal, then it gives CPU receives control to the handover. It controls the interrupt and handles the errors. And next it goes here, interrupt handle process data returns from interrupt. So it after rectifying the interrupts, it sends the data. So CPU resumes processing its interrupting task. So first the device drivers are sending some input output operations. So here if while sending input output operations, if an error raises or any interrupt raises, it gives some signal. It says that some buffering is happening, please rectify this problem. So it goes and sends to the CPU receiving. So CPU will be receive these interrupts and transfers the interrupts to handle. Then the interrupt handles the processes that returns from the interrupts. So whatever you are occurring here interrupts, it resolves the solution for that interrupt and gives us the processing to correct this interrupt task. So this is how the interrupt task is performed. So next, what do you mean by direct memory access? It is a way to move data between the CPU and input-output devices. So it is a way of communication transferring the data from CPU to input-output devices. When the user wants to access memory from input-output devices such as disk drive, the user must first inform the operating system that they are going to perform the operations. So when you are going to access the memory from input output devices, suppose you are fixing some disk drives. So you want to transfer the data into the disk drive. The user must inform to the operating system that you are going to perform this operation for sending the data to disk drive. So how this operations is performed to access the memory to input output. So you are sending the data to the disk drive. The operating system should know that you are transferring the data. After the knowing only, the operation will be performed. This is done by attaching a special command called interrupt request. So this is what interrupt request. You are sending some request. Handler routine for each device that needs to access. So whatever your interrupt request is sending, it handles the resource for each device and it needs to access it frequently. The interrupt handler routine then tells the user program when it should be ready for another task. So it should inform when the handler uses this user program is ready, then you are going to perform another task. usually using interrupts generated by hardware components like joysticks or network cards, and many even tell other processors running on the other CPUs. So here, when your interrupt is generated, so error occurred, the hardware components may be like joysticks or any network cards, or many other processing running on the CPU devices. Not only about what's happening that moment, but also when something has happened before, so they can take appropriate action as well. So it may be an error or interrupt occur, the action may be performed, an appropriate action or maybe another action to be performed. Why? Because here the error may occur due to the joystick or any network card or any other devices. So these are raising some interrupts. How we are going to solve this? So based on the CPU's devices or any input output hardwares, you can check these interrupts and you can correct it, and you are going to perform some appropriate action as well. So you are going to perform the action as well. That is what how you are going to share the memory from one unit to another unit. That's why when you are sending the data, you should inform to the operating system that you are going to perform some operations for transferring the data. That is what how you are going to access this input output buffering, and the data is sent, and you are going to receive some acknowledgement that we have received the data. So this is what how you are going to access memory directly. That is what direct memory access. So in this session we have discussed about input output hardware in operating system, and we have discussed about polling. Polling is nothing but to check the status of the software. And next interrupts, and next one is direct memory access. So if you have any doubts, you can comment in comment box. Thank you.